2014 paper 1 question 3 is a cubic function. X cubed plus 1 minus k squared times x plus k, where k is constant. Show minus k is a root. Okay, so if we put minus k in, our function will be equal to 0. Minus k cubed for x plus 1 minus k squared times k plus k. Is this equal to 0? Minus k cubed plus k minus k cubed plus k equals 0, 0 equals 0. So if minus k is a root, therefore x plus k, x equals minus k, so x plus k equals naught. Has to be a factor. So we factor, not factors, so we divide this in to my cubic using the box method. First term is x cubed, last term is plus k. We can see here we just have an x term, we've no x squared, so these two boxes will have to cancel. So we're dividing in x plus k to get x squared plus kx squared. Has to be minus kx squared. That will give me minus kx. This will give me minus k squared x. And look what we have here in terms of x. We have, well, it was the middle two terms, we have x minus x k squared, x minus x k squared. If we multiply this out, now we have minus k squared x, which is this guy, so we just have to have an x there to make this our x values. And x into x is plus 1, and we check is 1 times k. K, it is. So now we have a quadratic. In terms of k, we have x squared minus kx plus 1. So they ask us for the other two roots, so we can just use the quadratic formula. It's going to be in terms of k here. So minus b is k plus or minus the square root of b squared, which is k squared, minus 4 by 1 by 1 over 2 times 1. So my roots are k plus the square root of k squared minus 4 over 2, and k minus the square root of k squared minus 4 over 2. Part C asks to find the set of values for which f will have exactly one real root. Okay, for it to have one real root, the discriminant b squared minus 4ac would have to be less than 0 based on my discriminant rules. There is a video in LC Algebra on discriminant. Go and have a look at that if you're not sure what's going on here. So my discriminant is what's inside. B squared minus 4ac is in there, so k squared minus 4 would have to be less than 0. So k squared would have to be less than 4. So k would have to be less than, it's the plus and minus version, plus the minus 2. So the way we write this is big number on the right, small number on the left. Now let's just double check here. For this to be less than 0, if k was equal to 2, k squared minus 4 would be equal to 0. 4 minus 4 is equal to 0. But that doesn't mean that it just has one real root, because what we're talking about here is complex roots. So if k is equal to 3, we're going to get 9 minus 4, which is equal to 5. So you can see then that it's going to have more than one real root. So k would have to be slightly less than 2 and slightly greater than minus 2. But between these two values is what k would need to be to have exactly one real root.